Hello and welcome. In August 2023, India's Chandrayaan-3 mission delivered a soft landing on the moon's south pole, etching a new chapter in the global space history. That moment was not an ending, it was a launchpad. Today, the Indian Space Research Organization ISRO is not just aiming for the moon, it is mapping out a full scale, decade long expansion that is unprecedented in its scope. We are talking about the intensive period of 7 more launches in the immediate future. A highly complex mission to bring moon sample back to Earth by 2028 and construction of an independent space station by 2035. This is a story of India's cosmic leap, a roadmap that aims to triple ISRO's spacecraft production, expand its share of the global space economy, and solidify its place as a top tier space power. Stick around as we break down this monumental vision, mission by mission, deadline by deadline. So, before we look at the lunar surface and low Earth orbit, let's talk about the next few months. ISRO is now gearing up for one of its busiest phases ever, with 7 more launches confirmed before the end of the current financial year. This isn't just about launching satellites, it's about fundamental transformation of India's space infrastructure. These communication satellites and mix of mission utilizing the PSLV and the heavier GSLV vehicles. But one launch in particular signals a historic shift: the upcoming flight of the first PSLV entirely manufactured by Indian industry partners. This is not just a technological achievement, it's an economic one. It proves India's growing self reliance and its ability to scale production massively. The goal is ambitious. ISRO aims to triple its annual spacecraft production within the next 3 years. Why? To meet the surging demand for space missions and critically to grab much larger piece of the global space market. Currently at about 2%, India aims to reach 8% of the global space economy by 2030. Meanwhile, the path to putting Indian astronauts into space, the Gaganyaan mission, is firmly on track. ISRO Chairman V. Narayanan confirmed that while the schedule for some uncrewed test missions have been adjusted, the core plan to send the crewed mission in 2027 remains unchanged. This immediate surge of 7 launches is the vital engine of this entire plan. Each successful mission is a stepping stone, validating new technologies, training the workforce, and raising the financial capital needed to tackle the next enormous challenge, which is the Chandrayaan-4. The success of Chandrayaan-3 was historic. The challenge of Chandrayaan-4, however, is of a different magnitude entirely. This is India's first ever lunar sample return mission, officially targeted for 2028. A sample return mission is vastly more complex than a soft landing. Only 3 nations have achieved this feat: the United States, Russia, and China. Chandrayaan 4 aims to make India the fourth. So, how will this work? This isn't a single spacecraft, it's a meticulously coordinated ballet of 5 distinct modules, launched in a dual rocket strategy using the LMV-3 vehicles. First, the descender, the land near the Chandrayaan-3 site, the Shiv Shakti point, equipped with robotic arm and drill. It will collect and seal up to 3 kilograms of pristine lunar soil and different rocks, including subsurface samples. Second, one of the sample are stored and secured. The tiny ascender module launches off the moon surface, leaving the lander behind. It enters a low lunar orbit carrying the precious cargo. This is where the mission gets truly difficult and requires a leap in Indian technology. Orbiting docking. the ascender has to rendezvous and dock with the transfer module in lunar orbit. This requires perfect autonomous alignment, a capability ISRO has been developing through its SpaceX Space Docking Experiment program. The transfer module then takes the sample and crucially set a course back towards the Earth. The final piece, the re-entry module, separates, endure the fiery plunge through the Earth atmosphere and parachutes to a safe landing with the sample and completely intact. The scientific value of the sample is immense. They offer a direct window into lunar geology, the distribution of resources, and the history of our solar system, further establishing India's critical presence in the international lunar exploration efforts. This lunar focus is also why ISRO is collaborating with Japanese aerospace exploration agency JAXA or on LUPEX, the Lunar Polar Exploration Mission. This joint project will specifically investigate water ice deposits near the South Pole, a resource vital for future long-term space habitations. This lunar focus is also why ISRO is collaborating with Japan Aerospace Exploration, and this is why this joint project will specifically investigate water. This lunar focus is also why ISRO is collaborating. All right. So from the moon, we now look much closer to home, but into a much long-term future, the creation of permanent human presence in low Earth orbit. This is the Bharatiya Antariksh Station. India's greatest goal is to build, launch, and operate its own independent space station by 2035. It is officially named the Bharatiya Antariksh Station or BAS. This will make India the third nation in the world, alongside the US-led ISS partner and China's Tiangong, to operate its own independent crewed orbital outpost. The BASS will be a modular station, meaning it will be built in pieces or modules over several years. The first of these 5 key modules is targeted for launch surprisingly soon, which is 2028. This initial module will likely be a base for technological and robotic demonstration. By 2035, the completed station is expected to weigh about 52 tons and orbit at an altitude of approximately 400 to 450 kilometers. It will be capable of housing a crew of 3 to 4 astronauts or Vyomnauts for extended periods up to 6 months at one time. The station is the definitive answer to the question, why space? It will not just be a flag in the sky. It will be a national laboratory for cutting-edge research in microgravity, allowing Indian scientists to conduct experiments in biology, material science, and fluid dynamics that are impossible to do on Earth. Furthermore, the BAS is critical training ground for much larger long-term goals. Prime Minister Modi has directed ISRO to work towards landing Indian astronauts on the moon by 2040. The skills learned and technology validated, the experience gained on the BAS are now will be non-negotiable prerequisite for that ultimate crewed lunar mission. The Bharatiya Antariksh Station is more than just a piece of hardware. It will represent India's vision of becoming a self-reliant space superpower, one that contributes to the global science while pushing the boundaries of the human potential. So when we look at the entire roadmap, the 7 launches reinforcing the foundation, the credibility, of the complex Chandrayaan-4 mission, demonstrating deep space operational mastery by 2028, and the final goal of Bharatiya Antariksh Station by 2035. It becomes absolutely clear. This is not an incremental step by ISRO. This is a cosmic leap. This ambition is fostering a vibrant domestic space economy. The government space sector reforms has led to over 450 industries, 330 startups now working in Indian space ecosystem. This means ISRO's success is becoming India's success, driving innovation and creating high value jobs across the country. The next decade is set to be the most definitive in the history of Indian space exploration. We will see India not just reaching milestones but defining them, from bringing home lunar history to hosting astronauts in its own orbital outpost. So, friends, thank you for joining us on this deep dive into ISRO's future. What mission are you most excited about? Chandrayaan-4 or 2035 space station? Let me know in the comments below. Don't forget to like and subscribe and hit that notification bell for more breakdowns of the most exciting development in science and space and ISRO. Thanks for joining live. Thanks for watching, and I will catch you again in the next one.